All right, now we're ready to dive into similarity. So first similarity, very similar, funny, very similar to what we did with dilations. So figures that are similar have the same shape, but not necessarily the same size. Two polygons are similar if and only if their corresponding angles are congruent. So we preserve those angles just like how we talked about in the dilations video, and their corresponding sides are called proportional. A similarity ratio is the ratio of the side lengths of the corresponding sides. Okay. So just like that dilations video again, we compared B prime, A prime to BA, and we talked about that scale factor of 1/2. So just kind of go back and watch that real quick if you haven't done that yet. All right, so it's asking us, are these figures similar? So we have these two shapes that look pretty much the same, a little bit turned around. Now, what I notice here is this is a parallelogram, okay? And in a parallelogram, the opposite angles are congruent. So automatically what I'm looking at here is I'm seeing that those opposite angles are congruent. The adjacent angles are considered supplementary. So that would mean that these small angles are 55. So sure, 12 to 4 is all a ratio of 1/3, or 4 to 12 is a ratio of 3. But since I have different sized angles, no, because angles are not congruent. So for a similar shape, the angles have to be congruent, the sides have to be proportional. All right, so for this next one, all right, I've got these angles congruent, angles check out, that's good. So then we want to look at the ratios of the sides. So here, what I like to do is I consider something like a t-shirt size. This is kind of how I match them. So I'm going to call my small sides 11.5 because that's the smallest. This is my medium and this is my large. And I'm going to match those with the same thing. Smalls here, medium, large. So when you set up your proportions, I'm going to do small over small, small over small, medium over medium, large over large. The big thing here is I want the same shape consistently in the same position across my ratios that I set up. So this has to be, like if the green one has to stay maintain the top position on all of them. So for this blue one, that's always going to be the bottom part. Okay? And I'm just going to fill in those little spaces. So I've got small over small. So 11.5 over 13.8 equals 11.5 over 13.8 equals, now I'm on to my medium, so 20 over 24 and 30 over 36. So I matched my small, my medium, my large, my large. So now what I'm going to do in my calculator is I have to check to see that those proportions are all the exact same. So 11.5 divided by 13.8 is 0.833. 0.833 repeating. So obviously these two are the same proportion. 20 over 24 is 0.8333 repeating. 30 over 36, 0.833 repeating. So because all of these values are the exact same, I have something called proportional side lengths and congruent angles. So therefore, yes, they are similar. So when you're checking to see if something's similar, you have to verify that all of the sides satisfy that proportionality. All of the angles satisfy the congruency. All right, so what's the scale factor from the left to the right? Okay, so again, I'm going to do my small side to my small side. If I'm going from the left, this means it's my old image, this is my new image. So I always do my scale factor is new over old. Like KNO, so like knockout, get it? Okay. All right, so we have 24 over 20, whatever that value ends up being, 24 over 20, that is my scale factor. So that's 1.2. And that's the answer. Okay, similarly here we have what's the scale factor from left to right. Old, new. 25 obviously corresponds with 15, so you go new over old. So in this case, I'm obviously looking at this and I'm seeing that it's going to be a fraction less than 1. So I get 0.60 is my scale factor. All right. So if I'm giving you a situation where you have to solve for x, I have to be able to match what sides are proportional. The big thing here that you're about to see is we have this new notation. So before we had the squiggle with the 2 lines, and that meant congruent. Now I've got just the squiggle, so that means similar. So I should have a squiggle here. Okay, so if I'm matching, I have to set up these proportions. So I want to say, who is ML corresponding to? ML corresponds to RS, just like what we did with the congruency triangles. Similarly, now I'm talking about KL. So KL corresponds to KL TS. Notice that each of these times, this top triangle is on the top of my fraction, and this bottom one is on the bottom of my fraction. So now that I've kind of matched, I can go ahead and fill in the gaps to see what I need to solve. So ML is 91 over RS, which is X, KL 130, and then ST or TS is 50. So how do we solve from here? Maybe before you've seen the butterfly, but we're going to cross multiply. So I'm going to do 91 times 50 equals 130x. Okay, so 91 times 50, it's a big number, 4,550 equals 130x. Divide by 130 on both sides. X equals 35. So you're setting up these proportions to help you solve for those missing sides. All right, so similarly here, we're going to do this. We're going to go MS. Who does MS correspond to? MS corresponds to TS. So not what you would expect. And then we have that is equal to, because we already know they're similar, SN corresponds to SN, SU. Okay, now I'm ready to go ahead and just fill in those missing numbers. So MS is 36, TS is 63, SN is 4x, and 77. We're going to cross multiply. So 36 times 77 equals 4x times 63. 36 times 77 is 2,772 equals, now I'm going to do 4 times 63. And that's 252. X divided by 252 on both sides. 2,772 divided by 52 is a number, not a whole number. Usually you would get a whole number here. Oh, there we go. X equals 11. All right. So that's just kind of similar figures. Idea of matching those proportional side lengths, matching those congruent angles, finding a scale factor. Now we're going to go into some word problems. So I'm going to pause the video here. I'm going to do another video with the word problems. So I hope you feel pretty confident about similar figures. The word problems can get tricky because the hardest part is drawing some of them. So